Hello, everyone, and welcome to today's lecture. Today, we will be learning about the functions in Postgres SQL. Functions in any RDBMS are predefined keywords that perform a specific task and return a desired output. Functions in SQL and particularly in PostgreSQL can be subdivided into two major categories. The first category is scalar functions, and the second category is aggregate functions. Scalar functions are also referred to as single row functions, and aggregate functions are also alternately referred to as group functions. I will differentiate and distinguish between the two types of function after we have seen and seen and discussed some examples, and that will make it easier for you to differentiate between the two types of functions. Remember, each RDBMS has its own list of functions. Pretty much whatever one RDBMS offers, similar functions will be available in other RDBMS, but there may be some differences in the syntax. Since we are learning SQL on Postgres RDBMS, we will be viewing, or we will be basically discussing the functions available in Postgres RDBMS. But again, Microsoft SQL Server and Oracle will always have similar functions, and vice versa. There may be a slight change in the keywords or in the in the syntax. For a detailed list of functions available in Postgres, I'm going to share this link with you. This is the official documentation of Postgres, and this is an exhaustive list. Of course, we are not going to go and look at every function, but yeah, we'll be going through some of the commonly used functions. So let us start. My PG admin is already open on our sample database HR. Just a reminder, this HR database I'm going to use in all my video lectures. Look at my first video lecture to see how to create this HR database. It has three tables by the name of employee, department, and sal grade. So if you don't have this HR database for practice, you should go back to my first video lecture in this playlist. And that is where I'm going to show you how to create this HR database. So let us start. Select the name column, ename column from employees table. In fact, I'm gonna select ename comma job. Now have a look here. These are all my names and these are all my jobs. Now, when I inserted the data in the employees table, I used uppercase for all the names and all the jobs. And hence the values are in uppercase. But I may have a requirement that for some of the, some reports, I may want to see the names in initial capital, meaning I want the first character capital and the rest of the characters small. And let us say I want to view the values in the job column in lowercase. Now, physically, the data is saved in this case, uppercase. But for display purpose, I can change the case by using these two character functions. The first character function is initCap, and the second character function is lower. And when I run this, have a look what initCap does. Although the data in the column is uppercase, initCap is basically changing the case of the data, only for display purpose, of course. So now the first character is capital and the rest of the characters are small. Lower function, as you can see, is basically changing the case to lowercase. There is also a function called upper, and as the name suggests, it will convert the data in uppercase. But right now, I honestly don't have any data in lowercase to convert in uppercase. But if, let us say, if I had, some data in lowercase, I could have used this upper function to convert it into uppercase. We can also use any of these functions in where clause. For example, if you remember from the lecture on where clause, when I write like this, when I write like this, okay, now the values in the job class, in the job column are all in uppercase. So if I, let me show you that, okay? So all the values in the job column are in uppercase. So if I give if I give a lowercase manager value, it will not match. And I don't get a date. I don't get any data. One way to resolve this situation is I can convert all the values of the job column to lowercase and then match it with this value. The benefit of doing that is that if suppose this job column has 9 managers, three are in uppercase, three are in lowercase, and then there is a mix, there is no consistency in the case. So if I write capital manager, okay, if I write it like this, I will not get all managers. I will only get managers where the value matches the capital managers, right? If I write lower manager, I will again not get all the values. So this basically ensures that I get all the managers. It will take the job manager value, convert it into lowercase, and then match with the case. Now remember, we are using this function in the where clause. So this is going to be converted only for the comparison. In here, I am still writing select star, so that display will still be in the in the default case, whatever case it's there in the database. I am only changing it for comparison. If I want to change it for display also, then I will have to write the lower of job or init cap of job in the select list also. To start with, these are my scalar functions, the first category within scalar functions, and that is basically, so I'm starting with scalar functions, and within scalar functions, these are character functions. So I'm going to start with these three samples of scalars functions, character function category. Now, within scalar functions, there are subcategories. I'm going to start with character functions. We're going to see date functions and number functions. And again, the most commonly used functions within those categories. Let us see some functions of another category, and that is number functions. Now, as the name suggests, these are the functions that are going to work on numeric values. Let us see an example. Select the name salary and I'm going to do salary divided by 30. I'm going to call this daily salary. This is the column alias from the employees table. Let us run this. So what's happening right now is, okay, let me take another example. By the way, guys, I can only write like this also. I can write, let us say salary, select, and I can write any calculation. Let us say 3,200 divided by 30. And that's it. I just write this. I don't have to write a from something, okay? So it's giving me this value. I just need a decimal value actually. So it's not giving me a decimal. I think it's automatically converting it to an integer. Okay, so let us see another example of number functions. Now, sometimes when you're doing calculations, you may have the output in decimals. So right now, what is happening is when I'm dividing salary by 30, it is automatically converting it to integer. But if you are writing a calculation, if you're doing a mathematical operation where the output comes to a decimal, you can convert that decimal to an integer by using two number functions, namely round and truncate. So you can actually, write like this directly, 42.4 and 42.45. Let us see this. So I am not, so this is basically, I'm just writing print these two numbers, okay? It's something like that. So I'm not, my select statement is not targeted on a table. It is just, generic select statement. It's similar to writing just, print these two numbers. Now, I want to show you the effects of the function round on this decimal value, and again, the effect of round on this decimal value. So round is one of the number functions, and have a look what it does. If your calculation, if your output of the calculation is having a decimal value and you want to eliminate that decimal value, you want to round it to the next integer value. If your decimal is less than 50%, for here, for in this case, it is 42.4, round will keep the same number. Whereas if the decimal part is 50% or greater, the round function will increase it by one, round it up to the next integer number. And this is not SQL logic, this is basically mathematical logic. Even when you're using calculators on your, on your laptops or a general calculator, this is how it's gonna do. So this round function is basically used to round up decimal numbers to the nearest integer value. Similarly, I have another function called trunc, and have a look here. I'm going to do trunc of 42.4, and just for your comparison, I'm going to do a trunc of 42.9. Okay. What trunc does? Trunc does not take into consideration this is supposed to be 42.4, I'm sorry. So trunc does not take into consideration the weight of the decimal value, whether it is 42.4 or 42.9. I've intentionally used 42.9 because it is very close to 43. Yet, trunc will always give me 42. So in trunc, the weightage of the decimal component has no significance. It will simply eliminate the entire decimal and just return the integer component of the numeric value. So these are two number functions that may be used to round or truncate decimal values to the nearest integer value. The next category of functions that we're going to see will be in the date category. Let us see date functions. Now, before going to date functions, I want you to know that there is an inbuilt function in Postgres called current date. And if I just select current date, what it does is it simply shows me the current system date. This is often used when you're calculating the difference between days, or how many days has passed from a certain day to today. So this is used often. And every RDBMS has a similar function. For example, in Oracle, we have a function called sysdate, which is equivalent to the same thing. Now, select ename the hire date column from the employees table. Let us see the output. So these are all the employees, and this is the date of hire for them. Okay. Now, from within this hire date, let us say I want to fetch only the month component. So for that, I can use a function called extract, and I can say, okay, extract only the month from hire date. And this month keyword can be changed to day, year, month. Okay, any one of those components. Have a look here. So extract month Okay, so I think I'm not giving a semicolon in the above line, and that's why I'm getting an error. So this month should have been fine actually. And I'm going to just select this line and run it. And there you go. Okay, have a look there, guys. So yes, this is the actual date. This is how it is stored in the database. But if I want to extract only the month part, this is it. And same way I can extract day and years also if needed. Have a look. I'm going to just copy paste this. Very important SQL skill. And I'm going to call day. I'm going to call year. I could have written all of them in, same SQL line as well anyway. So run this and have a look. So from this date, the day part is 17. From this date, the day part is 20. And then the third one. So from this date, the year parts are those respective values. So I can extract part of the date using the extract function. This is helpful in situations like, let us say I have a question, list all employees whose hire date is in the year 1982. So I want a list of all the employees whose hire date is in the year 1982. Now it doesn't matter what day, what month of 1982, it just has to be 1982. For that, I could write where extract year from hire date, and that year should be 1982. Let us run this part and have a look here. So these are all the employees who joined in 1982. So they may be in different months, they may be on different days, but the year component of that value is what? 1982. And same way I could have done that for months or day also. So again, these are some of the commonly used date functions. There are many more date functions. There are many more number functions and character functions, but I'm just giving you the commonly or frequently used functions. Next, there is another useful category of functions that deal with nulls. Let me show you the behavior of null in any RDBMS, okay? So as we already know, null is basically missing value. Null is something that the user never entered in the database. Now in every and all RDBMS, if you use null in any calculation, the output becomes null. Look at this example. I have salary. I have a column called commission. Now, for many of the employee, the commission is not specified. It is simply null. Okay. Now, let us say I want to calculate the total salary. Okay. I want to calculate the total salary. And what's the logic of total salary? Adding salary and commission should give you total salary. So when I'm doing sal plus commission, it is fine for employees who have a valid value for, commission. So if you look at record number 2 and 3, Allen and Ward, salary plus commission, I'm getting a valid total salary. But null has this behavior in RDBMS that if I add anything to null, it becomes null. You cannot add, multiply, divide, subtract anything from null. It will basically result in null because null is missing information. Okay. You're telling the RDBMS to perform an operation against an unknown. Null is basically an unknown information. So the output becomes null. And imagine you're doing this big calculation, you're adding 5, 6 columns, and then you have some other, divisions and multiplications and all that. In all of that, if any one value is null, then the entire expression's output becomes null. Okay? Null is like a black hole, it eats up everything. Everything goes in and nothing comes out. To deal with such situations, we have certain functions in every RDBMS. And in Postgres, we have a function called as coalesce. This function is basically used to give alternate values when an expression or a column has null. So have a look here. I'm gonna do this. I'm gonna first use coalesce on the commission column. So what I'm gonna tell is coalesce commission comma 0. What does this mean? Let us run this and have a look at the output. So first of all, what coalesce is doing, and I'm gonna call this column just commission. Okay. Again, I'm giving it a column alias, so commission. So what coalesce is doing, wherever this first parameter commission is having a value, like in this case 300 and 500, it is returning the actual value. But wherever commission was originally null, it is replacing it with a 0, and we have chosen that 0. So what coalesce does, and there is no limitation on the number of parameters you can pass to coalesce. You can pass 10 parameters, 20 parameters. It will just return the first not null value in the list of values. So if commission has a value, it will return it. If commission has null, it will go on to the next value. And I can, if needed, I can give more values than that. Okay. So here, wherever commission is having a value, it is returning it. Wherever commission is null, it is substituting it with a 0. And this is, by the way, a column alias. Okay, just to avoid confusion, I'm gonna write that in a double quotes so that you know this is commission column alias. Now, I can use this in a calculation as well. Coalesce. So my first choice is salary plus commission. But if salary plus commission becomes null, then the salary itself should be considered the total salary. That's my logic. Okay. So if this becomes null, then ignore this commission. Just give me the salary and that will become the total salary. Have a look here. So what am I doing wrong? There it is. So in this example earlier, the 800 plus null was becoming null, but now what is happening? 800 plus null becomes 800 plus commission becomes null. So it goes to the next one. So I'm at least getting the salary as the total salary. And this is one of the functions to deal with nulls. Every RDBMS has a bunch of functions that can be used to deal with null values. It is in real time, it is important to have a systematic treatment of null values. This is something that is very commonly used. So these are your some of the commonly used character functions. Now, at the beginning of this lecture, I told you that you have scalar functions, also called as single row, and aggregate functions, also called as group functions. So let me take this example again. Let me run this. So remember, there are 15 records in the employee table, and all these three are scalar functions. So what they are doing, there are 15 inputs happening for name, job, and name and job, and then I'm getting 15 outputs also. So what these functions are doing, they are giving me one output for each input. That's why they are also called as single row functions. They work on each row at a time, one by one. Now, aggregate functions don't have any subcategory. Aggregate functions are pretty simple. I can write all the aggregate functions in one line. And namely, the aggregate functions that we have are, let us see them. You don't have a lot of category of aggregate functions. And we have function like sum, average, min, max, and count. Okay. Let me start by giving you a small example. Now, select salary from employees and have a look. These are 15 employees with their salaries. And I'm going to say sum of this salary. So, have a look at the output. Now, whether there are 15 employees or 15 million employees, when I do a sum, the result will be a single value. It doesn't matter how many records went into that calculation. It doesn't matter how many records are there in that salary column. The output will be a single value. Whereas here in the first line, if there are 15 records in input, there will be 15 records in output. If there are 15,000 records in input, there will be 15,000 records in output also. That's why those are called as single row functions or scalar functions, whereas this sum is a, a aggregate function, a group function. Why? Because irrespective of the number of records in the input, the output will be a single value. And now when you think of it, can there be two max? No. In a column, there will be only one max value. Can there be two minimum value? Again, no. If I want to take the average, can there be two average again or multiple average? No, there will be just one average for the entire column. And the last one is a function called count. Count will basically count the number of records in that. In fact, I should take count as the first one just so that you know that how many records are there in that column. Okay. So count has nothing to do with the data type of the column. It will simply count the number of records in that column. So have a look here, guys. There are 15 records in the salary column. The maximum value in salary column is 5,000, minimum is 800, the sum is this, and the average is this. These are your aggregate functions, also called as group functions. They work on a group of record to produce a single line of output. It doesn't matter if a column has 10 records or 100,000 records, the output will always be a single value. Now, as you can, as you can judge by the name, sum and average are purely numeric functions. So you can only use them for number columns. Count has nothing to do with the data type. You can use it for any data type. Count will basically count, just the number of records in a column. Max and min can be used on character, number, and date, all three. When you use it on number, I think the output is obvious, the minimum and maximum. When you use it on date, the oldest date value will be considered minimum and the highest or the latest date value will be considered maximum. Well, using it on character is not logically needed, but it will not give you an error. Okay, if I write select max of ename and max of min of ename. So it will not give me an error, although I don't know of any logical use of doing this. Okay. So what max is? Names that have a higher ASCII key, okay? Or names that have a that end with XYZ will be considered max, and names that are basically with ABC will be considered min. Okay. I don't know of any practical use of it, but it will not give you an error. That's for sure. Okay. So this is the details about the data types on which these functions work. Now I want you to have a look at this. I want you to understand this count. I can also say count of star, meaning I just want to know how many records are there in the table. And then I'm gonna say count of the commission column, then sum of commission and average of commission from EMP. Have a look at this. Count of star, meaning the entire table. There are 15 records in this employee table. Count of the commission column, I'm getting 4, meaning there are only 4 records that have a value in commission. All the remaining records are having null. Sum of commission is 2200. So if you add up the commission of all the employees, it is 2200. Now, this is where it becomes tricky. Average commission is 550. Now, when you see this, that there are 15 records in employee table, but only four commission values. So here you can see that count as a group function, as an aggregate function, is not counting nulls. It is ignoring nulls, right? Because that is why you're getting only four in this, because it is not counting null as a value. It is ignoring null. So all aggregate functions ignore null. And that is why you're getting an output for sum of commission, because it is only adding commissions where there is a value. It is ignoring all the nulls, and that is why you're able to get an output. Or else, as we saw, null will make everything null, right? So it's okay with count and sum. The problem comes with average. The correct average for employees would be to divide this commission, this total commission 2200 by 15. But right now, what is happening? For the average, this 2200 is getting divided by 4, not 15. So the average is inaccurate. I repeat, the correct average for employees table will be that the total commission, which is 2200, should be divided by this 15. That will be the correct average for the entire employee table. But right now, or the database is not dividing it by 15, it is dividing it by 4, and that is why you're getting 550 average. So that is inaccurate. So when using aggregate functions on columns that may have null, it is recommended to, deal with the null values. So as we learned, coalesce, use commission, but wherever commission is null, replace it with a 0. That's what we did earlier also, and we are doing it again. So when I do this, have a look, my average changes. Now what happened? When calculating average, every record was, considered, or every record was taken into account. Wherever commission had a value that was used, and wherever commission was null, a 0 was, substituted. So now this 2200 is getting divided by 15, and this is the accurate average commission of employees table. Sorry. So this is the average commission, alias. Okay. So the point to remember here is notes, aggregate functions ignores nulls. Hence, when calculating, so if it ignores nulls, it's not a problem with minimum, maximum. It is not a problem with, sum. The problem will only come with average. So when calculating average with nulls, always substitute nulls with at least a 0, okay? No, not at least, it has to be a 0, or else the output will be, inaccurate. Calculating, okay? Calculating average with nulls, always substitute with a 0. And this is it, guys. These are all your functions. We started with understanding that there are two categories of functions, and then we saw examples of scalar function, character, number, and date, and nulls, and then we saw aggregate functions. There are 5 aggregate functions, and we covered them. So yeah, go through these functions. As usual, the class notes will be uploaded on the Brightspace, and if you have any questions, we will of course discuss them in the class. Watch out for the next video.